Hello everyone. In this video, we are going to learn about locus diagrams. So we'll be having different circuits. So here we have considered RL series circuit. So again, there is a possibility of two cases. The first case, as you can see, R variable. So what could be the second case? L variable. Okay, so now we are talking about the first case. So this RL combination was excited by a sinusoidal voltage of V. Okay, so then a current I can circulate through the circuit. Okay, so now according to Ohm's law, what we can write? So I is equal to V by Z. Clear? Now let us go with the phasor diagram. Okay, so I'll be writing the phasor diagram here. So this is the voltage, supply voltage. Because inductor is there, so current always lags the voltage. So let me draw y-axis also. This is our y-axis. The current will lag. Okay, lag the voltage by how much angle? Let us say some angle phi. Okay, so now what I'm doing, I'm projecting x and y components. So if I project an imaginary line onto the x-axis, okay, so this component is called the cos component, and if I project an imaginary line onto the y-axis, then this component, vertical component, will be called as sine component. Okay, so now it's a basic mathematics. So consider this triangle. What is cos phi? Cos phi is adjacent. So let us say this as O, A and B points. What is cos phi then? So angle adjacent, that is OA, by hypotenuse, that is OB. So what is OB? OB is nothing but our current I. So therefore, what is OA? OA is I cos phi. So this component is there, no? So this is what? I cos phi. So similarly, if you do the problem for sin phi, so sin phi is opposite side, that is AB by OB. So what is OB? OB is nothing but I. So what is AB now? AB is I sin phi. So this portion is there, no? So this portion is called I sin phi. Okay, so let me erase these things. Okay, right. So we all know very well about the similar triangles. So here we can observe two similar triangles. So okay, these are the similar triangles, these two. Okay, that means what happens? I will erase this tick mark also. Okay, now, so what will happen now? So that means these two sides are equal and these two sides are equal. Okay, so now we are going to write the x and y components. Now tell me, what is x component? Okay, so let it be capital X. X means x component. What is the x component? I cos phi. Okay, so this is I cos phi. What is the y component? That is capital Y. Y component, that means I sin phi. So on what axis it is lying? On negative axis, negative y axis. So we need to put minus there. So y component is minus I sin phi. Now we all know very well. So what is the impedance triangle for RL? So this is the impedance triangle for RL. So this is R, this is XL, and this is impedance. How much angle it will make? Phi. Now from this triangle, what is cos phi? Cos phi is R by Z. What is sin phi? Sin phi is XL by Z. Now what is Z? Z is root of R square plus XL square. Now consider the current I. So I is what? V by Z. So that means V by root of R square plus XL square. Now you consider X component. So here I am writing capital X. So what is the X component? That is I sin phi. Sorry, I cos phi. So what is I? I means V by root of R square plus XL square into cos phi. What is cos phi? R by Z. So this is R by Z. Z is what? Root of R square plus XL square. If you do the calculation, you'll be getting VR by r square plus xl square. Call it as equation 1. Okay, so this one. Now, what you do, take y component. What is y component? Minus I. So minus v by root of r square plus xl square into sine phi, that is xl by root of r square plus xl square. So that means minus vxl by r square plus xl square. Call it as equation 2. Okay, so now we got x component equation and y component equation. So if I want to summarize these two x and y components, the best possibility is to square and add the two equations. So let us do. Okay, so now what we are doing, we are squaring and adding both the equations. That means x square plus y square. That means x component square plus y component square. So what is the x component? That is VR, that is v square r square by r square plus xl square whole square plus what is Vy? Vy is minus Vxl. If we do the square, so you won't find any kind of negative sign. So directly I'm writing V square. So V square xl square by r square plus xl square whole square. So what we can get as a common? So V square by r square plus xl square whole square. So what is the left over here? This is r square plus xl square. So one of the terms gets cancelled. So now what is the remaining expression? Let me write it as v into v by r square plus xl square. Okay, so this is x square plus y square. So now from equation 2, what we can write for v by r square plus xl square, what we can write? So we can write it as minus y by xl, isn't it? Okay, so let us substitute here in this equation. Now what you are getting? X square plus y square equal to v into, instead of this portion. Okay, so instead of that portion, what we can write? We can write it as, okay, 1 minute. Okay, so we can write it as minus y by xl. Okay, so it can be modified in this way. This is x square plus y square plus vy by xl equal to 0. So it can be even more simplified. So how we can simplify? Now we are going to add. Okay, so we are adding. So what term can be added in order to get a known kind of expression? Look at these two terms, y square plus vy by xl. So what should be added if I want to put that in the form of a plus b whole square? So obviously I need to add v by 2xl whole square on both sides. Okay, on both sides. So if I do, then I'll be getting x square plus y square plus vy by this is xl plus v by 2xl whole square. If I add the term here, I should add it on the other side also, so that the equation will be in a balanced state. So now look at this expression. So it seems to be a plus b whole square form. Okay, so now this is what x square plus y plus v by 2xl whole square equal to v by 2xl whole square. Okay, so now this equation can be compared with what? So this equation can be compared with equation of a circle. What is the equation of the circle? X minus x1 whole square plus y minus y1 whole square equal to r square, where r is the radius of the circle. So if you compare these two equations, what is the center? Center will be x1 comma y1, right? So what is the x1? 0. What is the y1? Minus v by 2xl. So this is the center. What is the radius? Radius will be v by 2xl. Okay, so now let us draw the phasor diagram. Okay, now I'm taking v as my reference. Okay, so I'm taking y-axis here also. Okay, so 0. Now for r equal to r1, because here in this case r is variable, so let us say for r1, so you'll be getting some current, no? So let the current be this one. So change for another resistance, so you get another current I2. So like that, if you have different resistors, you'll be having different currents, so I2 and so on IN. So now if you take the tips, okay, so draw the locus, you'll be getting the circle, semicircle like this. 100% the center will be, so what is the center from the equation? The center is 0 comma minus v by 2xl. So this should be our center. Okay, so this I1 is for r equal to r1, this is for r equal to r2 and so on. Okay, so in this way we can draw the locus diagram for RL series circuit with R variable. Okay, so now let us discuss the second case. What is the second case? R is fixed value and L is a variable value. So let us go with the second case. Okay, so here is case 2. Okay, so let me draw the circuit, resistor, inductor. So these were connected in series. So here L is variable. So this combination was excited by some sinusoidal voltage. Let it be V. Then some current I will circulate through the circuit. Now according to Ohm's law, I is equal to V by Z. Okay, now go with the triangle. So imprints triangle. So this is our imprints triangle. This is R, XL, Z, making an angle of phi. Now what is Z now? Z is root of R square plus XL square. What is cos phi? Cos phi is R by Z. Now what is sin phi? Sin phi is XL by Z. Okay, so keep it aside. Now go with the phasor diagram. So here I'm drawing the phasor diagram. So V is my reference. Let me draw the y-axis. Okay, now you tell me how what could be the current, how the current should be. The current will lag obviously because we are having inductor. So again this will be resolved into x and y components like we did in the previous case. This component will be I cos phi. Okay, so project an imaginary line onto the y-axis. So this component will be called as I sin phi. Okay, it is making some an angle phi. Okay, so now what I can take? So let me take the x component. So what is the x component? X means x component. What is the x component? That is I cos phi. What is the y component? So y component is I sin phi. Is that plus I sin phi or minus I sin phi? So on what axis it is lying on? It is lying on negative y-axis. So we have to take minus. Okay, so let us substitute. So what is I? I is V by Z. So Z means root of R square plus XL square. Okay, into cos phi. Cos phi is R by Z. So this is R by root of R square plus XL square. So there you get VR by R square plus XL square. Now go for the y parameter, that means y component minus I. So minus V by root of R square plus XL square. into sine phi, that is xl by z means root of r square plus xl square. So you'll be getting minus vxl by r square plus xl square. Call it as equation 1 and this one as equation 2. Now what we can do? Squaring and adding both the equations. Let's see. Now 1 square plus 2 square. That means x square, that is x component square plus y component square, which is equal to, what is the x component? That is vr. That means v square r square by r square plus xl square. We are taking square, so that's why whole square, plus y component, that is minus vy. So squaring means negative will be ruled out. So v square into xl square by r square plus xl square whole square. So take the common elements out. So this is r square plus xl square whole square. What is the left over here? R square plus xl square. So one of the terms gets cancelled. You'll be getting v into v by r square plus xl square. So now what we should consider? So in the previous case we have considered the second equation. Now you consider the first equation. So from first equation, what you can write? What is the first equation actually? So the first equation is, that is x component is equal to vr by r square plus xl square. So this is the first equation, no? So here this portion is there, no? So this can be written as v by r square plus xl square can be written as x by r. Okay, so use that in this equation. So from this, what we can write? X component square plus y component square is equal to v into. So instead of this portion, what we can write now from equation 1? This is x by r. Okay, so now what I'm doing, write y square first plus x square minus vx by r equal to 0. In order to have some a minus b whole square form, what we should do now? We should add some term. So what should be that added term? So now we are adding a term. So what is that? V by 2r whole square on both sides. Okay, on both sides. So if we add, then we'll be getting y square plus x square minus vx by r plus v by 2r whole square is equal to v by 2r whole square. So now look at this portion. It looks like a minus b whole square. So first I'm writing that part. Okay, that is x minus v by 2r whole square. Now go for the y square term. So y square equal to v by 2r whole square. Now you compare this equation with equation of the circle. What is the equation of the circle? X minus, so this is x minus x1 whole square plus y minus y1 whole square is equal to radius square. So now what is the center? So center is v by 2r x1 comma y1. Is there any y1 term? No. So 0. What is the radius now? This is v by 2r. Okay. Now let us draw the locus diagram. Okay. So here what I'm considering? I am considering voltage v vector v. Okay. So this is our y-axis. Now what is the center? Center is v by 2r comma 0. Okay, so if you draw the locus diagram, the center should lie on here. Okay, so other than that also we can find. So for x equal to x1, you'll be getting some current. So obviously inductor is present there, so you'll be getting some lagging current like this I1. So for different values of x values, so you'll be having different currents like this. Okay, like this. Now this is I2, this is I3, and so on In. So join the locus points. Okay, there you get the semicircle. 100% the center will be V by 2r comma 0 only. Okay, so obviously the radius is V by 2r. So in this way we can draw the locus diagram for the second case. The second case means inductor is a variable one. Okay, so for different values of x values, that means x equal to x2, you'll be getting here I1, you'll be getting here I2, and so on. X equal to xn, the current is In. So join all the locus points, you'll be getting the locus diagram for RL series circuit with L variable. Okay, so I hope this video helps you in drawing the locus diagrams for RL for both the cases. Okay, so in coming video I'll be covering RC series circuit for both the cases. Okay, so thank you so much for watching this video.